overview of base number systems. To help understand patterns in mathematical number systems, it is important to first get a grasp of number systems in general, which I will go over in this section. So the number 10 in general number systems. The mainstream Wikipedia definition of quote base or quote radix is shown below. Alright, so here's radix. In a positional numeral system, the radix or base is the number of unique digits, including the digit 0, used to represent numbers. For example, for the decimal or denary system, the most common system in use today, the radix or base number is 10, because it uses the 10 digits from 0 through 9. Radix is a Latin word for, quote, root. Root can be considered a synonym for base in the arithmetical sense. So let's consider the base 10 number system, which is comprised of the numbers 0 to 9. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So now incrementing past the largest single digit 1 is by convention equal to 10. So 9 plus 1, we restart, we add a 0, and now we have 10. Okay, so the number 10 signals a, quote, transition beyond the single digit base numbers 0 to 9, and it basically cycles back and to the 0. So we have basically goes to 9, and all of a sudden we put a 1. So yeah, basically cycles all the way back here and goes here, and we just increment by 0 there. And then the next one will be 11, 12, 13, and so on. So yeah, so this transition also restarts the same 1 to 9 counting scheme, but with an extra 1 digit indicating the digit to the right is added to 10. So in other words, we'll have 10, 11, or 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9, or we could write it as 10, then 10 plus 1, 10 plus 2, 10 plus 3, 4, 5, 6, 7, 8, all the way to 9. So we have this extra 10 there indicating we've gone past, so that's going to be 10 digits, or 9 plus 1 digits. And likewise, the transition beyond 19 gets restarted at 20, and so on for for 30, 40, etc. So we have 1, 2, 3, 4, all the way to 9, then we jump to 10, 11, 12, so we have 1, 2, 1, 3, 1, 4, all the way until 19, and now the next digit, there's no other unique base digit, so we have to jump to the 2. So now we have 2, 0 all the way, 20, 2, 0, or 20, 21, or 2, 1, 2, 2, 2, 3, so and so on. Now incrementing past 99, because we do this all the way for 30, 40, all the way to 90, and then incrementing past 99, because now you have both these digits are the maxed out of the base digits, the biggest number, which is 9. So this restarts to 100, so we just add 2 zeros now. So 99 plus 1 is 100. Likewise, incrementing past 999 restarts the count from to 1,000, or restarts at 1,000. So we have 999 plus 1 is going to be 1,000. And then transitioning further just means adding more zeros. We have 10, 100, 1,000, 10,000, 100,000, 1 million, etc. So we just add more zeros, or we write this as 10 to the power of 1 for the 10. 10 to the power of 0 is going to be just 1. So 10 to the power of 0 equals 1. That's just the by convention. I'll include that later. Alright, so likewise, going backwards requires crossing the quote 0 transition and follows the same pattern but with negative numbers. So if we go backwards, this is 1, 2, 3, 4, all the way, this is positive 1. So go backwards, we just add a negative sign. So we have negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way there. And then we just add, now it's going to be negative 10 as a transition. Then we go negative 11, negative 12, or 1, 2, 1, 3, etc. So we just add a negative sign there. Yeah, so we've covered base 10, but let's look at an example that involves different bases, just to show that this number 10 can be viewed as a transition beyond the base number system. So if we look at the base 4 number system, so to illustrate the use of the number 10, let's consider the base 4 number system, which has the following single-digit integers. Note that integers, again, are just whole numbers. So we have 0, 1, 2, 3. So these are four single digits of the base 4 system. So you include 0 there. And now incrementing past the biggest number, biggest integer 3 or biggest number 3, the usual convention is again to set it to the number 10. So 1, 0, we just restart. So 0, 1, 2, 3, and then 10. And 3 plus 1 is defined as 10 in the base 10 or base 4 number system. And incrementing further, we get the usual as expected. So we have 0, 1, 2, 3, and then 10. Then 1, 1, 1, 2, 1, 3, and then we get to the 20, and we keep going, 21, 22, 23, then 30, because remember, it's we're going in 4s, so this is every 4, but now, yes, the next one's 31, 32, 33, but there is no number 4 in either case, so it's maxed out, so we jump to 100. So this is the 100th number there. I mean, it's number 100 in base 4. And then we go the same exact as the base 10, but we cut off at the 3. So 101, 102, 103, and then 110, or 110. Yeah, so we just jump there. Similarly, the transitions are in the same notation as in base 10. So we have 10, 100, 1,000, 10,000, 100,000, 1 million. But again, it's in base 4, so they don't actually equal the usual 1 million that we think of in base 10. And then you could write this as well in powers form. So 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, 10 to the power of 4, 10 to the power of 5, etc. And yes, a reminder that the actual value of the quote 10 is dependent on the number system, even though the notation is the same for different number systems. So 10 in base 4 is not equal to 10 in base 10. So now let's look at another example just to illustrate it further. So base 10 number system. Lastly, let's consider the base 10 or binary system, which is widely used in most computers. So the integer for base 2 are 0 and 1, so just 2 of them. Incrementing past the biggest integer 1 gets a similar sequence. So we get 0, 1, then 1 plus 1 is going to go to 10. Then the next one's 1, 1, and then next is add 2 zeros, then 1, 0, 1. And so then we have 1, 0, 1, 1, 10, 1, 11, and then we have 1,000, and again, we just do the exact same thing. So we have this 1, 0, 1, 1, 0, 1, 0, and then, so 1, 1, add another 0, 1, 0, 1, add another, just increment past that. Actually, I think I made a mistake there. So this should be 1, 1, 0. Remember, this is 1, 1, 0, 1. So then the next one, this needs to increment, and that goes to 0, and then this is going to be 1, 1, 1, 1, and then there's a 10,000. So yes, that should be right. Let me know if I made a mistake anywhere. But yeah, it should be correct. So anyways, so once again, the transitions are in the same notation as in base 10 or base 4 number systems. And that's, again, 10, 1,000, 100, 1,000, 10,000, 100,000, etc., 1 million, etc. 1 million, where, again, in base 2, or binary does not mean 1 million in base 10 or base 4. Or you can write it as 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, 10 to the power of 4, 10 to the power of 5, etc.